Hi everyone, this is Dr. Mohammed Al-Ahmadawi, a geophysics and a founder of Smart Line Geophysical Survey company. Today I will speak about, or I will discuss how to add interpretation to the 3D GPR data by or using RADAN software. And this video is one of a series of learning video that I will creating during the coming days. This series of videos will orientate to the junior geophysics that want to learn the most advanced GPR and ERT data processing and interpretation. Before starting this video, let me introduce my company for you, and let me discuss with you the services that we introduce to our customers. Smart Line Geophysical Survey is a small survey founded in Iraq during 2022, and this small company is a specialist in near surface geophysics, and it's focused on the applying ground penetrating radar and electrical resistivity method for near surface application to find what are hidden beneath the earth surface. We are in Smart Line Geophysical Survey focusing on 4 main surfaces. The first surface we introduce to our customers and the client is data processing and interpretation. As a small company, we have a variety geophysical softwares, and these softwares are usually used to process and interpret both GPR and ERT data. Then after processing and interpretation, we create a 2D and a 3D maps, and these maps usually exported and inserted in high quality geophysical report, and then provide the final report to our customers. The second service that we are introduced to our customers and clients is training courses and workshop. We have a variety training courses and workshops that fit with our clients' needs, and we are willing to train their teams with high quality aspects and facilities to ensure that these teams will be able to do a high performance field work as they requested from their executives. So our training courses are fit and our high quality courses can be provided to our customers. The third service that we are focused on is the field investigation. We already did several field investigations and field works to our customers using ground penetrating radar systems and electrical resistivity tomography systems to find utilities or to find voids under the ground, to map the foundation of the buildings of historical buildings beneath the earth's surface, and etc. So we have the ability to do different field investigation to find different targets just below the earth's surface. The other service that we are focused is supplying our customers with the cutting edge GPR systems and ERT systems, and already our clients and our customers are certifying with this service, and they provide us a good feedback about their new systems that are supplying by us. Now let me starting our short learning video. As you can see, this is the interface of RADAN software, and you know that RADAN software is created by GSSI manufacturer, and GSSI produce high quality GPR systems around the world. So you can see that I already imported a GPR data, and this GPR data consists of many or several GPR profiles that collected in X and Y direction in the form of a grid. You can see that each profile has a length about 10 meter in X-axis, and also each profile in Y-axis has the length of 10 meter. The spacing interval between every two profiles is only 25 centimeter. So because this data is collected in a grid mode, we can create a 3D view for this data by aligning all these profiles in a 3D file. Then the RADAN software will create a 3D visualization for this data. Now, in this form, this data is not migrated data. So to create an accurate 3D view for this data, I need to migrate this data. At the meantime, and for the purpose of this video, I will not process this data as the processing will take long time. I applied only migration on this data. The purpose of applying migration is to collapse the tails or the axis of hyperbolas and moving these tails and put all the energy in the top of the hyperbola. So as I told you, the full processing will make this video is very long, so I only applied migration process to this data and changed or moved all the energy from the tails of the hyperbolas to the top of the hyperbola, as you can see in this profile. Then I will hit the 3D view, and you can see this is the 3D view for this data. As I'm moving the depth slices up and down, you can see that there are several linear reflections on these slices, and this actually represent a net of underground pipes in the area. So what I will do here, I will add my interpretation. I will try to draw these pipes and present them in the 3D view, then export these pipes to AutoCAD software, or export them as an image to put them in the report. Now I will starting to add my interpretation to these data and learn you how to add this data in a simplest way. There are two ways to adding this interpretation. You can add this interpretation using 2D interactive ribbon in RADAN software, and this way will work on both the 3D view or the depth slice in the 3D view, and also on the 2D profile. So to start to add your interpretation, make sure that you starting from the first profile, then hit signal point bottom. After that, choose the interesting reflections that you think this reflection is represent a pipe. Then as I told you, hit the top of this reflection, and when you moving between the profiles, you can see that this reflection is repeated along the profile. So what you need is to add interpretation to this reflection. If you can see on the depth slice, there is a linear drawing, looks like a pipe is appear on your GPR data. By the way, if you control the depth of the slices, you can see that this interpretation is coinciding on the linear reflection at this location. If you continuous adding interpretation to the selected reflection, you can see on the 3D view that the linear drawing is extended further when you adding more and more interpretation to your data. And by the way, if you can see that some hyperbolas are not coincide or are not collapsed on the top, and this is occurred because there are a bunch of hyperbolas, and if you need to migrate them accurately, you need to select several velocities and tell the program to make migration according to these velocities. You can, because the hyperbolas are occur on at different depth on the GPR profile, so you can choose let's say 2 velocities or 3 velocities and tell the program to average these velocities and make the best migration for your GPR data. Now I will continue adding interpretation following this specific reflection until this reflection disappear. This is mean that all the profile in x-axis are having the same reflection that represent a linear reflection, or in the actual they represent a pipe. Now I will return to the first profile and choosing another interesting reflection and following this reflection until it disappear. So I will at this time I will choose a new target. Then I starting adding an interpretation. By the way, you can see that the new target is named as a rebar 001. You can change the name of this by going to the table and it only to hit it and write, let's say, pipe 001. Also you can change its color from pink to, for example, blue. Then close. You can see that this dot is changed from pink to blue. Now I will following this specific reflection along my profile, and you can see that this reflection is occur at a depth more than the first reflection. Let's move the slice down. You can see that the new interpretation is added to the depth slice. I will go to table and I will increase the size of that specific drawing. You can see that the size of the dot is changed, but the size of the interpretation on the depth slice is not changed, and this is occurred due to maybe bugs in the software. But if you close the software and open it again, you will see that this interpretation on the slice is in its real size. Now I will continue with following the same reflection, and you can see also that this reflection is the depth of this reflection is changing from deep to shallow. This means that this particular reflection represent a pipe, and this pipe is not putting in a horizontal level, but it's a dipping pipe. To sure, you can go to your depth to your 3D visualization and see that this interpretation is not a horizontal interpretation, and this means that this pipe is a pipe that occur or represent an inclined pipe or dipping pipe. Let me make the the depth slice shallower. You can see that this is the real profile. If I go to down, you can see also the same reflection are repeated with the strongest amplitude. And actually, if you return to the unmigrated data, you can see that this reflection represent two hyperbolas, and these hyperbolas are coinciding. This is mean, and because these hyperbolas are coinciding and has the same axis, this hyperbola mainly reflected from the BCV pipe, and my focus was on the first hyperbola, and this hyperbola represent the top of this pipe, while the second hyperbola will represent maybe the lower edge of the pipe. So this hyperbola will not interesting to me, because this hyperbola will give me a wrong depth for this pipe, while the first hyperbola will give me the exact depth of this pipe. I can apply the second method by going to the 3D volume option ribbon, and then choosing a 3D interactive. In this way, I can only applying my interpretation on the 3D view of my GPR data. So any change I will make on the GPR 3D view will not appear on the GPR 2D view. Let me show you that. Before that, I need to choose an interesting linear reflection. Then I will add my interpretation. As I told you, you should choose a free pipe, and you can see that the first target or focus will be named by a pipe. So I can just double click on the beginning of the linear reflection, then double click on the end of the linear reflection. You can see that the GPR or you can see that RADAN add an interpretation to this particular linear reflection. If I want to add another linear reflection, I just go to the 3D interactive option and hit a new target, and I can add a new interpretation by double click on the first by double click on the first of the linear reflection, and double click on the second or the end of the linear reflection, and go on for other reflection using the same way. You can see that a new interpretation is added to the your GPR data, and this new interpretation will not appear on the 2D profile, because this interpretation are added only to the 3D volume of the GPR data. Now I can visualize or preview this interpretation in different ways. For example, I can hide the profiles. Also, I can hide the depth slice, so I can so one can see the distribution of these pipes in a 3D view. Also, I can tell RADAN software to export this interpretation to use them further using AutoCAD. Also, I can tell RADAN to export this 3D data or a 3D interpretation using as an image, and then I can use this export to put them in my geophysical report and provided it to my customer. This is what I want to learn you in this video, and I hope this video will meet your needs, and this video is enough informative for you.